All right, let's get started. Good morning, everybody. Hopefully you'll stay nice and cool on this hot day. I'm not a summer person. I like fall and winter, even spring when it's cool or nice out, but summer, I'm not a summer. All right, good news. Yesterday, I finally found out. I've been asking and she hasn't made up her mind. Finally, yesterday she did, she being the department chairperson, and that is there will not be a departmental or ACS final for 12-11. And that's good news for you, because those are multiple choice tests that are not good. Well, that's my personal opinion. So what that means is last night and this morning, I saw a mistake and I modified it again. This morning, I posted a new syllabus that's been modified. And this is for your benefit. It helps you out even better. All right, let's take a look at it. All right, let me just move something. I tried something and it wasn't working as well as I hoped. This is better. All right. Thumbs up, people. Can you see grading and evaluate? Thank you. All right. What I've done is originally we had 5 tests and a final. And that was my way of sort of, I'll use the term neutralizing or making it better for you because of the departmental final. Without any departmental final, one, I've changed this. Instead of 5 tests, we now have 4 tests. Also, I've moved test 2 back by a week. This is a good thing because this will give us extra time for you to practice. Because remember, test 2 is probably the hardest test of the semester. I could feel myself rushing. This way I don't have to rush. Now, what this also means is instead of having test 5 and the final on the 23rd, we'll just have the final, which is my final. That's one major change, and it is a major change. And because of that, the grading evaluation, I forgot, we'll take the sum of the 3 highest of 4 tests. That's 47% of your grade. The final will be 32%. Relax, I'll explain why. The lab is still 21%. If you go back and look at the old syllabus, the total labs in the final were, not labs, in this test in the final were 79%. It's still 79%. So that hasn't changed. Did I mess it up again? I'm going to have to go back and, or am I using an old copy? Hold on. I think I am using an old copy, and on Blackboard, the correct, let me just change this. All right. Now your percentage is the sum of the 3 highest hourly exams, the final exam score, your lab total, extra credit, which will coming up in about a week, times 100, still divided by 632. What this does is gives you probably a better chance of getting a better grade because we're not taking the departmental final. Now, except for the last time before I taught 12-11, I've been teaching 1105 for a while now. I don't have to do it departmental or ACS. This, my actual final, relax, will be 200 points, but the average on the final, all the years I've given it, and I give similar ones, is usually about 170, 180 points out of 200 plus. there are 10 bonus points on the final. I can do that now. And 170, that doesn't sound, or 180, divide that by 2, that's like 85 or 90 average on hourly exam. Since you people are doing good, you should do real good on the final. And this, I feel a lot, how should I say, relieved for you people, because it will help you out. Okay, any questions on the, one other thing. Before that, first of all, any questions on that part of the syllabus change? Going once, twice. All right, the other thing I did, which I mentioned I was going to do, if you look at the lab schedule, notice I now have lab numbers so you can see which one is it. Because what I didn't do in the grade book is write the name of the labs, but lab 1, 2, 3, 4. Also, what I did for today's lab is I changed the order. We'll do balanced chemical equations. It is in the assignment area. Got until next Tuesday to get it in. This way I can grade it, get it back to you, and you can now have time to study for the test, having seen how well you did on balancing chemical equations. One thing a few of you are confused on, any lab that's in all red is on Labster. When there's a mixture of like equilibrium and instructor handout, you'll only be graded on the instructor handout. Now, where it says periodic table, some of you haven't done that. Go back, go in. You can, if you have problems, let me know, contact me, I'll help you. And just answer 1 or 2 questions and you'll get your 11 points. Because Labster is not, needs some extra work by the originators, which I tried to offer my help, but they don't seem to want it. Too bad. I could have helped them a lot. But anyways, that's the other change. This right here has been changed. Everything else is the same. All right, any questions about the syllabus? Going once, going twice, darn. All right. Now I'll check and make sure I have the right version because I have 2 versions on this computer. I think I picked the older one. All right, let's start something new. And before I start that, this is the only occasion I can think of this semester that what we do in the lecture we'll also do in the lab, meaning something the lab will be on is in the lecture, which will be on test number 2. And this is a very important skill set. So important on test 2. Usually I have 9 to 12 points on what I'm going to be teaching this morning. Take good notes or go look at Zoom on YouTube. All right, this is from chapter 8. Remember the yellow part in chapter 8, I deleted. It's just a repeat from chapter 6. And important skill is writing and balancing chemical equations. I'll never ask you, but what is a chemical equation? It's a written statement that uses symbols and formulas instead of words to describe changes occur in what we call a chemical reaction, when you mix 2 chemicals together and something changes. Now, the convention is, and this you don't have to write down or anything, but I still want to go over it, the correct formula of reactants. And before I even do this, let's go over here. I'm going to ask my thumbs up. Do you see a blank page now? Thank you. All right. Let's look at a very basic chemical equation. And what this means is A plus B. The plus sign is considered and. You could also say A and B are reacted together and they make C. Now, here we have an arrow. And at the base of the arrow, these are called reactants. You should know this. Also, if you've worked in industry like I have a good part of my life, a number of decades, it's also called, which more likely or not, I will say, starting materials. So at the base of the arrow, A and B are your reactants or starting materials. At the head of the arrow, C is called the product. And if there were more than one product, we'd call it the products. So this is a chemical reaction. It tells us A and B react to make C. So let's look at a chemical reaction. And here we have hydrogen gas reacting with oxygen gas, and that's what the plus sign tells you. Hydrogen gas plus oxygen gas make water. And that actually happens if you want. It's an expensive way to make water, but on the space station in the past, or some of the Apollo moon rockets or capsules, they did make water this way for the astronauts, because even though it was expensive, it was a cheaper way, a lighter way of carrying water on a spacecraft, which weight is important. Now, I'm going to make you work. Which are the reactants? Which are the product or products? You figure that out. All right, time's up. And the question is, what are the reactants? And the reactants are hydrogen and oxygen. Remember, reactants are at the base of the arrow. What are the products or product? In this case, it's this water. And remember, at the base of the arrow are the reactants. At the head of the arrow are the product or products. That's always true. Now, when you write a chemical equation, these are givens that you should always follow, and I do. The correct formula of the reactants, which also I call starting materials, are always written on the left side of the equation, base of the arrow. The correct formula of the product or products, some people call substances produced, I never have, are always written on the right side, head of the arrow. The reactants and products are separated by an arrow pointing toward the products. Plus sign are used to separate, as you saw, reactants or different products, like we had hydrogen and oxygen reacting together. That's why I had H2 plus O2. Now, something is important in a chemical equation. First of all, they must be, whenever you write one down, which I will always do, they must be consistent with the experimental facts. If you reacted hydrogen and oxygen together and didn't get water, then what I wrote was wrong, but it's not, you do get water. Now, this is very important. There must be the same type of atoms of each side on both sides of the equation. When you have a chemical equation, or I'll also call it a chemical reaction, I guess I should use equation, and because of what's called conservation of mass, you never create, you never destroy atoms, never, in the chemistry I've ever done. And therefore, a balanced chemical equation has the same number of atoms of each element and the same type of elements involved in the reaction on each side. Again, because of conservation of mass, you never, or matter, not mass, conservation of matter, you never destroy or create atoms in a chemical equation. You must have the same number and the same type of each element involved in the reaction on each side of the equation. When that isn't true, you have to balance an equation. And an unbalanced equation is brought into balance by adding coefficients. I'll teach you what that word means. It's the number in front of a chemical to the equation to adjust the number of reactant and product molecules and also atoms that are present. Remember the torsion balance or teeter-totter analogy. That's for me to remember. I will. All right, let's look at this reaction again of water. And the question is it's balanced? And balancing is just like balancing your checkbook. But here we're dealing with atoms, and molecules are really atoms and not dollars and cents or whatever country you're in. And here on this side, how many hydrogen atoms do we have? 2. On this side, how many hydrogen atoms? 2 in water. On this side, how many oxygen atoms do we have? 2. There's 2 in O2. How many here? O1. So these are not balanced because you have to have the same number of atoms on both sides. And notice now I have 2 oxygen and 1 oxygen, so I don't. So let's go back and figure out. Now, you cannot change the formula of a molecule. Hydrogen can't be H3, oxygen can't be O, oxygen gas. It's always O2. Water is always H2O. Well, here I have 2 oxygen. If I have 1 here, how can I make that 2? You change the number in front. This is called the coefficient. I think I spelled coefficient right, but don't bank on it. And when there's no number, the coefficient is assumed to be 1. But since I need 2 oxygens on this side, so it's balanced, I'll put a 2 in front. And now 2 times 1, 2 oxygen, but how many hydrogens? 2 times 2, 4 hydrogens. Ah, 4 hydrogens. And this side, I only have 2 hydrogens. How do I make this 4? I can't change this number, but I can change the coefficient. That's now 1. I want 4. 2 times 2 is 4. So I'm going to make this 2. And now 2 times 2 is 4 hydrogen. And now I'll check. And I'll see, oh, look, 4 hydrogen. And I'll have here 4 hydrogen. And here I have 2 oxygen. And here I have 2 oxygen. So now this is a balanced chemical equation. How do I know that? It has the same number of atoms on each side of the arrow. And what this really means is when you do the reaction, you need 2 molecules of hydrogen reacting with 1 molecule of oxygen. The coefficient, when there's a number 1, you don't see anything, makes 2 molecules of water. And we're going to find out either today or Monday how important those coefficients are in a balanced chemical equation. And the answer is extremely important. All right, let's try one more. Oh. Now here, if you take sodium and react it with chlorine, go on YouTube, this is a neat thing to see, you get sodium chloride, salt. This is an expensive way to make it. You can get it from the sea or mine it, which is most. I work for a company, Axo Nobel, and one of the divisions was called, major division, Axo Zout. Zout is the Dutch way of saying salt. Axo was mainly a Dutch company before it bought out Nobel, a Swedish company. But anyways, is this balanced? Well, 1 sodium here, 1 sodium here, looking good. Ooh, 2 chlorine here, 1 chlorine here. It's not. So I'm going to share the fun and let you try and balance it. Why don't you balance it? You can't change the formula, but you can change the number in front, the coefficient for each one. And if we were in class, I'd be looking around and saying, when you're done, look up and smile. But here, I guess I'll ask you to give me thumbs up. Some of you might be faster. So let's give everybody time because this is new. Hurry up, no. I'm in a good mood. I did all my shopping. After I talk to you, I get to do something which needs to be done. That's unclog, which is starting to clog up my bathroom sink. Ooh, that reminds me, after we do this, I'll do a public service announcement. All right, looks like everybody's done. Let's do this. This is not balanced. How do we get it balanced? I have 2 chlorine here. I have 1 chlorine. How do I make that 2? I put a 2 in front. So now I have 2 chlorine here. But now I have 2 sodium. I only have 1 here and I need 2 on this side, so it's balanced. I can't put a 2 here. Students like to do that. change the formula. No, sodium is always Na, but I can do this. And now I have 2 sodium, and now I'll check, is this balanced? And we'll do our counting: 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Yay, it's balanced. And what this tells you, even though my handwriting, I got to practice more of my writing on the tablet this weekend, is 2 sodium atoms react with 1 chlorine molecule to make 2 sodium chloride molecules. And that's how you balance it. All right, time out for a public service announcement, or help my students, which is always a good thing. Hang in there while I go somewhere on the internet. All right, thumbs up, people. Can you see hair and grease bottle on there? Yes, you can. All right. I'll come back to it. When I first bought the house I'm living in, which, wow, it's back in '98, that's a long time ago, within a couple of weeks, my kitchen sink plugged up. And being new and in the house, I thought, all right, let's do it right. I called the Roto-Rooter guy. Came out, very nice person, put his thing in there, did his stuff, rooted out that, and lo and behold, it was unplugged. Within about 5 days, it was plugged again. By the way, I don't put any grease or anything like that down there. I'm an organic chemist. I know better. That's how you plug up a sink. Never pour grease or fat or even oil, vegetable oil, down your sink. Put it in a Ziploc baggie, put another one, throw it in your garbage. I always do. So I called them up because it had I think it was a 3-month or 6-month guarantee. And he came out, very friendly, did it again. Thank you. And within about a week, it clogged up again. I wasn't happy. Not because of the money I spent, because I was working a full-time job. And I had to stay home and wait for this guy to show up. And I was missing time. I was salaried. It wasn't the money, it was the time. Because that time I had to make up because things had to be done. So now the guy, oh, I'm really sorry. Well, hey, things happen. And he says, I'm going to use this special stuff. And I said, let me look at the label. I look at it and I say, no, that's, in my mind, that's garbage, because I know all those chemicals in there. I'm an organic chemist with many years training, and those surfactants aren't going to get the job done. He did that, routed it again. A week later, lo and behold, it's clogged. So I figured I'm not wasting my time, forget about the money. At that time, I was making a 6-figure salary, so I didn't worry about $50 or $75. It was more me wasting time. And I went to my local Home Depot. And if you ever go to Home Depot, at least by my house, the people there are very friendly and knowledgeable. And I went to the section where they had all the drain cleaners, and there's a whole long wall of them. And I pick up a couple of bottles, and I'll teach you later about this. I see hydrochloric acid, hydrochloric, which I know how the chemical reaction to unclog a sink, why that will work. And nice, one of the people worked there, can I help you? And I've had a flash of intelligence. Sometimes that happens to me. I asked him, all these drain cleaners, which one does the plumbers use? And within a millisecond, he says, this one. I pick up the bottle, and it's the only one that doesn't have hydrochloric acid. It has a base, and I'll teach you later on the semester. I'll re-go through the story, a base, and I'll tell you the story of how I learned never to discuss chemistry with people at Home Depot who work there, but that's another story. And the product was this, hair and grease cleaner. Fancy name, not. It's the only product on that whole shelf that's in a heavy plastic bag, Ziploc, and on the bag it says use proper eye protection and rubber gloves when using this product. And they're right, you should. It's safe, but still do. And I took it home, followed the directions. I had rubber gloves, being a chemist. I had safety goggles. I even put on a lab coat I had at home, poured it down the sink, followed directions, boom. It was unstopped. And that product, for about 10 years, maybe longer, it's stopped up again. I always keep a bottle in my house full, and I did it again. It's been 12 years now and it hasn't clogged up, but I've never had a problem like bathroom sink clogged up. Must be some of this I'm losing or whatever. And when I get done talking, I'll do that. Over the years in my organic chemistry and this one, I've had many students use that product with success. Also, my brother-in-law used it both in his kitchen and bathroom with success. So if you ever have a clogged sink and you don't want to pay a plumber, this is the product to use, and it works real good. It's the only one on there I would use. The other thing, which when I had a plumber out for something else, not deal with that, we were talking about drain cleaners. Says, yeah, that's one I used, and said the other ones have acid in them, and something I hadn't realized, that in the drain from my house, there's a spot that goes from my house to the sewer pipes outside, and that length and house my age that I own are made of metal. And you don't ever want acid like HCl and Drano or anything like that touching metal, because they'll react and eat away that pipe. And he said, you know, that's another reason. I said, well, you taught me something new, and I thanked him. That's when they changed some valves and done some other work that I wouldn't want to do. All right, let's go back, now that I've told you that story, to balancing chemical equations. All right, let's look at something else, another one of these. I got the angle right on my pad finally. Now, this compound C3H8 is called propane. You don't have to know that, but I thought I'd tell you that. And propane is the stuff you get into white bottles for your barbecue. And when you react it with oxygen and a little spark, this is called combustion. You get CO2, carbon dioxide, water, plus not a chemical. What you also get, and this is not part of the balanced chemical equation, you get heat, a flame, and that allows you to cook your food on your barbecue. But let's look at this chemical equation. Is it balanced? 3 carbons here, 1 here. It's not. Now pay attention. This is a pro tip from a pro, Dr. White. When you're balancing chemical equations, always leave oxygen, hydrogen last. When you're balancing chemical equations, always leave hydrogen, oxygen last. And that makes your life easier. You don't have to, but it's quicker and easier, less stress, which is a good thing. So let's go and see how you do this. Well, I'm going to follow my own advice. Notice on this side, I have 3 carbons. And let me just do a quick check. Thumbs up, people. Can you see the reaction? Thank you. All right. So how do I get on this side 3 carbons? Well, I can't change this formula, but I can put a 3 in front there. So now I have 3 carbons. Well, since I'm lazy, I'm going this way. All I have left are hydrogen and oxygen. I'll do the hydrogen. Here I have 8 hydrogen. Uh-oh, I only have 2 here. How do I get it to 8? Students try and change this to 8. There's no such thing as H8O. It doesn't exist. But if I need 8 hydrogens, which I do, you need the same number of atoms on both sides of the chemical equation, the arrow. How do I get this to 8? Well, I'll multiply it by 4. That's a 4. Hold on. That's better. And now 4 times 2, 8 hydrogen. Now I'm going to look on this side because the only thing left I have is oxygen. On this side, I have 2 oxygen, but how many oxygen do I have? Remember, when you're balancing an equation, you have to count all the atoms. And this side, how many oxygen? 3 times 2. That's why I had that on test 1, how many different atoms in a molecule. That's 6 oxygen. That's better. And over here, 4 times 1 plus 4 oxygen, that equals on this side 10 oxygen. I put the line there so you know it's not the number 100. Over here, I have only 2. Oh, look, 2 goes into 10. How many times? 5. And now I have 10 oxygen. Now, one thing I like to do, so I can make sure I did it right, I'll do my accounting. How many carbons on this side? 3. How many on this side? 3. How many hydrogen? 8. How many hydrogen here? 4 times 2, 8. How many oxygen here? 10. How many oxygen? 6 plus 4 is 10. Ta-da! It's balanced. And that's how you do it. Remember, leave hydrogen, oxygen last. Since you should have some fun. Oops. Why don't you try this one for yourself? Balance the following chemical equation. And on a test, I'd have, I don't know, 3 points each. Remember, if you finish early, give everybody time. Remember, this is something new. Remember, leave hydrogen, oxygen last. That's my tip, and it always works for Dr. White. All right, everybody done? Nope, not yet. Remember, you're all rookies, so if you're having problems, it's something you just learned, some of you. You didn't have this in high school. For those who don't have video, if you can do a thumbs up symbol. If you're done, please do that. Thank you, Brooke. Thank you. For those of you who don't want to do thumbs up, you can do a thumbs up. They have a thumbs down. I don't think so. And by the way, Shahana, if I'm pronouncing it right, I learned this in 8th grade too, because I was in an advanced science class. But some of you may not. All right, let's go ahead and do this. What do we have? If we look here, we have 5 carbons, 1 carbon. Leave hydrogen, oxygen last. I'm going to follow my advice. And if I have 5 carbon here, how do I get 5 carbon here? Because you need that. And the answer is put a 5 there. I'm done with carbon. Next, I'm lazy. You could do oxygen, but I'm going to do hydrogen because I have 12 hydrogen here. Oh no, I only have 2. How do I make that 12? Well, 2 divides into 12 6 times. 6 times 2, 12 hydrogen. Now, all I have left is oxygen. Here I have 2. How many on this side? We have to add all the oxygens. And 5 times 2 is 10 oxygen in CO2 when you have a 5 in front for the coefficient. The coefficient is the number in front. And then in water, the coefficient is 6. So 6 times 1 is 6. And if you add that up, that's 16 oxygen. Now here we have 2 and you can't change that number 2. How do you make that 16? 2 goes into 16 or divide 16 by 2 and the number you get is 8. Now I should tell you that I can make a better 8 first of all. I'm going to have to practice the next couple of days just doing my penmanship on a tablet. That's better. And now we have 16 oxygen. And now I'll do my check. 5 carbon, 5 carbon, looking good. 12 hydrogen, 12 hydrogen, still looking good. 16 oxygen, 16 oxygen, success. Really looking good. Now, before I go on and do some more of these to show you some skills and also let you try it, let me show you one thing. If you go to the assignment area Blackboard, and I'm going to ask my thumbs up people, everybody see the lab on this? Thank you. You'll see this is the lab. For this lab, you're going to balance the equations in the next 2 pages and submit those balanced chemical equations as the assignment area. You print this out, you can write right in front or right underneath or just copy it. Now, this I stole from somewhere. Shh, don't tell anybody. And this is a question right here. What is the sum of the coefficients for I? And I'll let you, that's a question. Then the other page has more chemical reactions. Now, what I will never do on a test, again, all you have to do is balance all these. And by next Tuesday, upload your balanced chemical equations to Blackboard assignment area. Now, since this is from something I sort of lifted, on there, you might have a case, and I think there are two of them, where the equation is already balanced. So you can just write down already balanced. However, on my test, I will, if I ask you, and it will, on test 2, there'll be at least 3, probably 4. Hold on, 3 dimensions. Does it seem like it's coming right at you? 4, yes, probably 4 balanced chemical equations, 3 points each, 12 points. And if I ask you to balance an equation, you will have to balance it. The answer already balanced will never be correct on any test or final of mine. Why? Because when I was a student taking chemistry in college, the teacher put 1 or 2 down like that. I didn't think that was fair. You asked me to balance an equation, then I should have to balance an equation. And that's just who I am. So on a test, unlike the lab will have a couple where they're already balanced, and you write that down, but on a test, it will always be true. If I ask you to balance an equation, they're unbalanced, and you got to do something. All right, let's move on to some more things about balanced chemical equations. Oh, someone just asked, what's the letters G and S? Someone just answered for me, gas and solid. I'll never use those for the most part ever on a test or in class. It's something you can put down. I'll teach you later on when we get into what's chapter on solutions. There's a certain one called AQ, aqueous, which means water. And I'll teach you that when we get to it. But G and S stands for gas, for G, S for solid, and if you see an L, that's liquid. The 3 states of matter, which you learned. All right, let's look at the following. This is an interesting special case. And notice here, I have 2 oxygens, and here I have 3. There's no way I can multiply using a whole number, and coefficients are always whole numbers, 1, 2, 3, 4, 5, can have 1.5 or 2, but a whole number times 2 and get the number 3. And there's no way I can multiply a whole number times 3 and get the number 2. So what do? First of all, I call this even odd case or example. And the easiest way I found to answer the question, how do you balance it? When you see an even odd, like here and here, you say, what number do both of those go into to give a whole number? And the easiest way is multiply 2 times 3, and you know that's 6. So if I multiply this times 3, 2 goes into 6 3 times, I have 6 oxygen. If I go over here, how do I get to 6 oxygen here? I multiply that by 2. Now, aluminum, I have 4 aluminum. And how do I get 4 aluminum on this side? You do that. So now I have 4 aluminum. So the trick to even odd is multiply the 2 numbers. This side I had 2 oxygen, the other side, the odd one, 3. 2 times 3 is 6. So how do I get 6 on both sides? Because I go both 2 and 3 will divide into 6 to give a whole number. So 2 goes into 6 3 times here. 3 goes into 6 2 times here. Now I have to balance this, which I did, and I'll do my final check. 4 aluminum, 4 aluminum, 6 oxygen, 6 oxygen. And now I know they're balanced. So make sure if you see an even odd, you do that trick. Because some of these, if you don't know that trick, you can spend a half hour and still not get it and be very frustrated, which is not a fun thing. This is an interesting reaction, which you never want happening on your car. Iron, Fe, plus oxygen makes ferric oxide, you know as rust, which you don't want on your car. And why don't you balance it? Your turn. Have fun. When you're done, smile or give me a thumbs up. I see people are still working or their thumbs up button broke. All right, I think everybody's done. Let's take a look at this. Now, first question is this balanced? If we come over here, you'll see 1 iron, 2 iron. It's not. So I could do that, but that won't help me right now because if I look here, I have 2 oxygen and 3 oxygen. Once again, even odd. Now, what number do both of these go into to give a whole number? 2 times 3 is 6. So I want 6 oxygen here. How do I get that? 3. I want 6 oxygen here. How do I get that? 2. So now I have my oxygens done. How many iron do I have? 2 times 2, 4 iron. And this side, how do I get it? 4, similar to up above, but, and now I have 4 iron. And something I like to do, you don't have to do this on a test. You don't even have to write the stuff under here on a test, but I would, because this helps you make sure you did it right. 4 iron, 4 iron, 6 oxygen, 6 oxygen. And that's how you balance a chemical equation. That was fun. Let's do another one. Ah. And the question is this balanced? The answer is no. 1 aluminum, 2 aluminum. I'm going to let you try this on your own. Now, remember Dr. White's advice, leave oxygen, hydrogen last. Why don't you try this? Go. This one's a little tougher, but follow my advice, leave hydrogen, oxygen last. And when you're done, give me a thumbs up, or I see people doing that. A few other people are still working on this. Thank you, Jennifer. Oh, by the way, while you're doing that, someone raised a point where they're from, and Dr. White likes food from many different cultures, and you're probably familiar with, and I pronounce it wrong, Palak paneer, and I know how to make my own. Plus, I like it in good Indian restaurants. It's one of my all-time favorite dishes, which is why I learned how to make it myself. It's almost as good as what you can get in a good Indian restaurant, like on Devon Avenue, if you've ever been on Devon Avenue. All right, let's do this because we're running out of time, and I always like it. We have 1 aluminum here. We have 2 aluminum here. Why did I do that? Not oxygen, hydrogen? Because I'm going to follow my advice. So how do I make 2 aluminum? Simple. Put a 2 there. That's done. Now here, hydrogen, I'm going to wait till last. Sulfur. Here I have 1. Here I have 1, but it's in a bracket, 3. So I have 3 sulfur. How do I get 3 sulfur? Put a 3 there. So I now have 3 sulfur. If you notice, I got aluminum done, sulfur done, but now I have hydrogen and oxygen, so I'm going to do hydrogen first. 3 times 2, 6 hydrogen. Over here, oh, I've got 2, but how do I make that 6? Put a 3 there. So now 3, and I'll write it up here so you can see it better. 3 times 2, 6 hydrogen. And now I'll look, all I have left is oxygen. 3 times 4, because don't forget you changed the coefficient, is 12 oxygen. And this side, 3 times 4 is 12 oxygen. I see someone might have had a question. Thank you. Can you see it now? Hold on, let me go to my thumbs up, people. Can everybody see it now? Can you see it? Thank you. Okay. All right, let me go through it again. To get 2 aluminum, 2 there, 2 aluminum. Next, there was 1 sulfur before I put the 3 on this side. 1 times 3 is 3 sulfur. To get 3 sulfur, I do this. Next, I'm going to do hydrogen because all that's left is hydrogen and oxygen. 3 times 2, 6 hydrogen. How do I get 6 there? Put the coefficient 3, 6 hydrogen. All that's left is oxygen. Now I change the coefficient here. So 3 times 4 is 12 oxygen. And here I have 4 inside the bracket, but there are 3 of them. Remember, the coefficient here is still 1. 4 times 3, 12 oxygen. And I'm going a slightly late. Hang in there. 2 aluminum, 3 sulfur, 6 hydrogen, 6 hydrogen, 12 oxygen, 12 oxygen, success. All right, important thing. Test 2 is hard. Do the practice problems. You should do those. I changed the date, so you got plenty of time to do that. Also look at the videos, both Zoom and the YouTube I sent out from 11:05 that I go over this in case you need an extra. I teach the same thing in that class, just about the same way. You'll see if I'm telling you the truth or not. And with that, don't forget the lab today is you download those balanced chemical equations, you balance them, then you upload it, and then that's how you hand in that lab. Remember, at least 1 or 2 are already balanced, but I'll never do that on a test. With that, have a nice rest of the day, nice rest of the week and weekend. I'll see you on Monday. If you have any questions, always feel free to email me. With that, gehen gesund, be healthy, and I'll see you on Monday. Bye. Oh, I forgot to do this. Really goodbye. Gehen gesund, be healthy.